Hello, everyone. Thank you for being here. My name is Yaron Schneider. I'm a CTO and co-founder of a company called Diagrid that I started in January of 22. I am the co-creator of the Dapr project as well as Kida. Both of them I created together with a gentleman here. Mark, you can raise your hand. While we were both at Microsoft, and yeah, some time has passed since then. And I'm going to start off with this very ominous warning that we see here. And be careful what you wish for, you just might get it. You probably have heard this phrase in multiple movies, podcasts, whatever, during your life. This is very timely for me because I just had my birthday 2 days ago, so I did continue wishing for no YAML, but did not get it. But really, what we're going to be talking about today is what happens when you wish for something and when reality really catches up and allows you to get the tech that basically makes those wishes come true. So what do I mean by that? I will make the claim that all of us here and the entire DevOps movement and application engineering and software engineering are basically inside of this very hall because we wanted to automate everything. Not necessarily because we're lazy, maybe that too, but because we really want to make things efficient. And not just that, our organizations, the one we work for, will become very efficient if we're able to automate everything. And I will make the case that any technology within the CNCF is all about automation. And yeah, that has worked fairly well for us, hasn't it? We've automated stuff and then came up with other tools to automate the stuff that we automated, to automate the stuff that we automated. And it's going to be a never-ending cycle just continuing until all of eternity, it seems, because CNCF projects are continuing to pour in. And for good reason. They are, I mean, some of them are solving really good problems and they graduate, but the projects are not getting archived as fast as they're coming in. So this landscape is basically going to grow a whole lot more, and it grows every year. So, you know, if you don't take my word for it, let's take a few examples. Kubernetes, all about automating containers and container runtimes, automating Linux C groups, automating just PIDs in the Linux kernel, IP tables and routes, and everything you know from the networking API in Kubernetes, all of those services automated by things like Envoy, automated by service meshes like Istio and Linkerd, and then there's tools to automate service meshes, and it goes on and goes on. But this has created a multi-billion-dollar industry, and the reason why many of us are actually here. But then we finally got the solution we're all after, AI agents. That's the epitome of automation, isn't it? Now there's a solution that can allow us to automate everything we're doing. Actually, it's going to do it so well, we're going to be automating ourselves out of our own jobs. Maybe, if we do good enough of a job here in this room together, collectively, making agents grow. But I don't want to be so bleak. I actually want to talk about tech that's exciting and about what it can do for us, and it can do a whole range of things, but we also need to be very conscious about the pitfalls when we give it agency and autonomy, things that it expects in order for it to operate very well. So let's just take the single LLM. This is just your typical run-of-the-mill OpenAI, Anthropic, whatever, pick your LLM kind of workflow. It generates content, but it doesn't automate our every being just yet. We give it a problem, and it gives us back a response, but it does nothing to automate. So its ability to actually make our lives as developers, software engineers, as CTOs, as architects, much easier, and the overall business is kind of limited. But this is really where agents are coming in. And this is something that is not very complex. It's basically the same LLM, but now we're giving it access to tools. And tools, for those of you who are not aware, is basically a way to connect an agent to your underlying ecosystem, to connect it to your digital infrastructure. Do you want an agent to understand your database? Great, connect it to your PostgreSQL. Give it access to it. So what if it now can come up with queries that bypass the tenant IDs you put inside of your columns to make sure that you're multi-tenant? It doesn't matter. But agents will basically do that. They will take the tools you gave them access to, and they will use them to achieve the one goal that you put in front of them. And they do this by reasoning, right? You give them a problem, they reason, they loop over it, they look to see if they have the tools in the toolbox, and they do the job. But that wasn't enough, right? Because what if the agent can't actually do its work? Well, it's okay, because now we've got multi-agent systems, and you've got an agent that can talk to another agent and see if that agent can help solve the problem. So complexity, of course, grows, but with it, the promise for full automation. The agent doesn't know what to do? Great, just connect it to other agents in the registry and let it find another one that does know how to perform that work so that we don't have to. And this is all great. They can handle unpredictable environments, kind of, unless ChatGPT comes back and says 2 + 2 is 5, it's all going to go great until that happens once every 100 call. But essentially, this is the promise of AI systems that are decoupled, that help each other tackle really complex problems by having specific domain knowledge about the problem at hand. And this brings more complexity. Each one of those reasoning agents I just showed you here is going to talk to multi-agent systems, and it's just going to continue growing. But agents are really only useful if they're given autonomy, because it's a very simple equation. The more autonomy you give them, the more they can actually automate. And automation, of course, is the epitome of all business needs because it reduces overhead, reduces costs, toils, and just allows us to do more, and that translates into ROI. So the more autonomy we give it, the more we're getting out of it. But the problem is that with more autonomy, there is more risk of failure because pretty much for the last, I would say 40 years, we've been taught to deal with systems that are very, very deterministic. And when I mean deterministic, take this workflow that you see here on the right. Let's say that you want to execute 1,000 workflows that basically process 1,000 documents. And you write your business logic as a developer and you expect it to do something given a certain input and then act the same way when it's done. But this is not the case with agentic systems because we are introducing non-determinism at 2 critical junctures. So before we talk about determinism, non-determinism, and why we need to make that reliable, let's take a look at what happens if that specific workflow fails. If it fails and you have an agentic system that now decides how to integrate and operate with whatever systems you're giving it access to, it's basically going to run, if you're telling it to run 1,000 times, it's going to run from the very beginning if it fails. So you made it to step 999 out of 1,000, failed at it, and then it's just going to pick back up. So, usually for many systems, it's fine because you don't have costs associated with literally every activity that you operate. But with agentic systems, you take out the LLMs, and they're basically just microservices, the same ones we've been talking about since, well, depending who you ask, 2008, 2009, 2010. But now every step is basically consulting an LLM provider, and that can become extremely expensive. And if you're running your own GPUs on-prem, well, then you're just going to be hawking that hardware, making your entire system unreliable. It's a great way to go bankrupt or just provide a very bad experience for your users. And then, you can have multiples of those. You can have multiple agents running these multiple workflows, executing thousands of documents, just growing in size. And with the great food comes the appetite, right? After you've deployed one agent and you were able to show ROI, your manager is going to come and say, well, why don't we automate this and this and that? And suddenly you're going to have these fleets. And this is, in my view, what's going to happen beginning and mid of 2026. We're going to have fleets of agents making their way into production. I know most companies right now are kind of like in the POC stage, but it's coming up fairly quickly. So we talked about determinism, non-determinism. Non-deterministic is basically the situation where we've got an agent and you give it a prompt and you connect it to a bunch of tools, right? So a tool can be something like get the weather, get the latest financial forecast, talk to the database, see HR complaints, whatnot. But software up until now, we've basically written it in a bunch of steps. We wrote unit tests or tests for it, and they can run reliably. We know what's going to come out on the other side. But with an agent, it's actually creating real-time dynamic workflows. And this is something we as an industry have not prepared for, because one prompt is basically going to choose 5 tools out of 10 and execute them in one order. And then a different prompt is going to choose 8 tools out of 10 and execute them in a completely different order, with just literally one word that's changed from the prompt. And how can you even think or start thinking about debugging something like this and being prepared for what happens when it fails? So observability into your workflows is extremely important, yes, and reliability and making sure that these agents basically pick up where they left off is the most crucial thing organizations are going to run into when they're taking these workloads into production. And we've also got the semi-deterministic workflows. This is what most people are doing today with agents. They have their workflow, and that is basically a process that they know and understand. And maybe I'll show an example if we have enough time. Let's think about a research agent, right? We know what it needs to do. It needs to get the prompt, review it, come up with queries, search the internet, get the responses back, scrape the data, synthesize, analyze, continue if it needs more data, rinse and repeat until it's satisfied, and if the LLM provider isn't down, of course, or AWS, that chance, and then it's going to complete, and everything's going to finish successfully, and we're going to have a deep research agent. And this is semi-deterministic because we know all the steps in advance, so we're inserting non-determinism only at one point, and that's the LLM right there before the end. So we've got a deterministic workflow. We know what needs to be done, but we take the risk that the LLM is going to come back with a totally different response that we just didn't mitigate for. Both these non-deterministic and semi-deterministic operations need reliability at the highest scale, more so than we've talked about before. And to mitigate those risks, we need, in my view, and also in LangGraphs and a lot of other AI companies today, an engine that allows them to take deterministic and non-deterministic workflows and basically pick up where they left off. Automatic failure recovery, making your agents stateful from the ground up. And it needs to be low latency, it needs to give you a durable execution, and you really want the agent to be able to persist each and every step in something that is more complex or at least a lot better than just regular checkpointing, which doesn't account for things like Kubernetes, right, where you're running multiple instances. Most agentic systems today, unfortunately, that I see are running a single instance. Once people start scaling it out, then they have state store errors trying to perform e-tags on the database, and you've got 5 or 6 or 7 workflows now executing the exact same workflow in different places, making your costs go triple in less than several seconds. And this is a problem. You need failure-proof reliability and orchestration for these agentic workloads. Because otherwise, every time your agentic system fails, and the more you introduce them, the more you're going to pay, and the more errors and basically shutdowns and outages you're going to be seeing. And observability is really top of mind here, because if we execute a workflow and we need to fix that workflow, or we need to tell the agent to not do something because that is leading to catastrophic responses, we need to know exactly and as soon as possible what is wrong in the agentic workflow, whether it's deterministic or non-deterministic. So in the CNCF ecosystem, we have introduced back in March together with NVIDIA, Dapr Agents. Dapr Agents is an agentic framework written in Python. It's part of the Dapr project. And so this is an agentic framework that is part of CNCF. Really, it's the only vendor-neutral programming agentic framework today. And it allows you to do what pretty much any other agentic framework allows you to do, only it has one very big advantage. It makes sure that all of your agentic workflows, no matter how big or how complex or how many clusters they're running or how many documents or videos or audios you're processing or how many tools you're executing or how many agents you have running and even how many network failures you're seeing, they're going to make sure that those agents, when they come back up, they're going to be hydrated with their state. They're basically going to be saving it up until the moment they crashed, and then they're going to continue. They have multi-agent eventing. If you're connecting multiple agents, well, how do you do that? How do you make sure that agents cannot insert poison pills and poison messages through SQS or Kafka or Pulsar to other messages? And how do you wire those agents up to basically start working on behalf of streams? This is what we call ambient agents, but their architectures are still kind of tough to create. Dapr Agents has all of that built in. You literally don't have to do anything except for telling Dapr Agents which pub/sub component you want to use, and then it'll connect all of your agents together. And you're able to also define which agent can talk to what agent. It can run anywhere. It runs particularly well on Kubernetes. If you go to this link here, Dapr Agents, you'll see that we've got plenty of Kubernetes examples. Dapr runs very well on Kubernetes itself, and Dapr provides the underlying workflow, state, and eventing APIs and primitives for these agents. So Dapr really is a foundational infrastructure for AI. If you don't know Dapr, come to my maintenance talk tomorrow. I'll do a brief 101. But Dapr is essentially a developer toolbox allowing developers to focus on business logic and not infrastructure concerns. It's a graduated project. We donated it to CNCF from Microsoft in September 21, and it graduated last year. It has all of these APIs, including workflow orchestration for general business logic, pub/sub, secret management, configuration, service discovery, things that allow you to really ship fast and not need to think about how you interact with the underlying infrastructure. But what we found was that these yellow/green, I don't know, I'm red blind, so I'm not sure what color this is, those boxes there are really foundational for AI. Why? Because we've discovered that Dapr has a great mechanism to let services discover other services and create ACLs between them. Now we can apply those to agents, not just to Dapr agents, but also to LangGraph agents, LangChain agents, and Crow AI agents, and AWS Trans agents. And we're going to be coming up with more and more content to show you upstream in Dapr how to connect those systems to it. And then the conversation API allows you to basically abstract over other LLMs, but it's also taking care of a really important problem. It has built-in PII data obfuscation. So if you have anything like an email, a name, a credit card number, or anything that you don't want going into the other party provider, Dapr is going to obfuscate it, both for data that's going into the LLM and also coming back from it. pub/sub is a great API we found to create ambient agents, and state management is a great way to let agents, Dapr agents, but not just, create and save all of their conversational state in Dapr-backed state stores, which come with built-in telemetry, observability, and a whole bunch of things that you want in a database or when talking to a database. So without further ado, let's do some demos. Now, the internet here, as you might have noticed, isn't great, and we're going to be very hopeful that we are able to run this thing to completion successfully. All right, so let's switch over to VS Code. And let me actually start, because I do have some time, with the semi-deterministic workflow. So we're going to be taking a look at a deep research agent that I've written that basically takes a query and then it goes off and searches the internet and comes up with results. It's pretty much like what you'd get if you're running a deep research agent with OpenAI or others. By the way, I forgot, unfortunately, to put the link into this deep research agent into the slides. I'm going to try and do it quickly after, but if not, just come to me and I'll shoot it over. So let's take a look at what's actually special about this research agent. Let's take a look at the workflow itself. Is this big enough, or should I zoom in a little? Zoom in a little? Okay, you got it. It's looking weird for me, but yeah, we'll be okay. Okay, so why do I call this non-deterministic? Because we have a bunch of phases. We have a scope and plan. Scope means we get the input topic, we scope it out. Then we're going to create a plan for how do we intend to tackle the research. Then we are going to find sources all across the internet that basically contain enough data for us to be able to answer a research assignment. And here I'm connecting to a third-party API to do that. And as you can see, every activity that finishes just passes off its output as the input for the next one. And this is very sequential. This is basically the blueprint for deep research agents. And then we're going to take the sources and we're going to search for them, read the data that we got back, synthesize them, as in make it better, make it more concise. And then why is this a semi-agentic workflow, not just a regular workflow? Because it does have some autonomy. It's actually going to review itself, and it's actually going to ask itself if it needs more data. And if it needs more data, it's basically going to continue and do a rinse and repeat over the sourcing, the note, and the review process until it's satisfied, and then it's just going to generate the final report here. Now, this takes a while, like a few minutes, so I'm not going to run this to completion, but I do want to show how important reliability is. So we've got about like 9 calls, and each one of them has an I/O operation attached to it, or an external LLM call, or a call to a third-party provider like I have with Tavily here, which is the API I use to search for the data on the internet. And everything, thank you, and everything costs a lot of money. And so what we have here is just regular business logic. These are just regular Python code. This is just regular Python code as you'd write. The implementation itself isn't as important. I'll give you the code after. You'll see it. You'll be able to run this thing. But what's really important is the fact that they are all activities. And by putting all of those different activities here, we're essentially making them immortal, so to speak. If they die, they will reincarnate with their data, basically where they left off. So our topic of choice here is something simple to start with. Assess the viability and risks of small modular nuclear reactors for grid decarbonization by 2035 in the US. And we're going to be running this. So I have the Dapr CLI running locally. Dapr CLI is just a local developer tool that allows me to run the Dapr workflow engine, and then it'll also run my Python code. Yeah, I ran a lot of Dapr stuff recently, as you can see here. Okay, yeah, let's do this. I think this should work. I had a specific command. Let me just find that. Yep. So we're going to be running this, and this is a Dapr app ID. App ID is just giving a workflow a name, and then the Dapr CLI also just allows me to, for convenience, run the Python script together with Dapr. But this isn't strictly needed. And of course, when you're running on Kubernetes, you're going to have a sidecar running next to your pod, which is the Dapr sidecar. Yeah. So let's run this real quick. And we're going to see a bunch of logs. So these are the logs from Dapr. It's starting up. It's all good. And now we're going to start, well, paying money and calling to the LLMs. So as we can see, we started outputting. So we have 1, 2. Basically, in each one of those activities, I print 1, 2, 3 to see exactly where we are. And now we're at point 3. Now it's coming up to a step called read, which is basically reading all of the data that was returned. Now we're going to scour the internet. But I'm going to do something quite nice. So step number 4 now is actually the most I/O intensive and cost intensive operation that we have. And I'm just going to crash the thing and kill it. And now if we basically spin the thing back up, what we're going to see is that it's picking up right from where it left. It's not going to start the thing. And it's executing a new one because this is what the code does. It executes a new workflow every time. But the important thing here is that we are starting off with app 4. So if you're running these agentic workflows at scale and you have 10, and then you're going to grow to 20, and then to 100, and then to 500 steps in an agentic workflow, and you're going to be scaling out those systems, then durability for your own peace of mind, for your own ability to continue your business without needing to get money from the bank to finance those LLM calls is extremely important. So this is the durability in the aspect of a semi-deterministic workflow. Now, I want to switch over and demonstrate Dapr Agents. Can we still see my screen, by the way? Yes? All right, cool, great. So this is a Dapr agent. This is all it takes to write an agent. This is what you know if you've been seeing LangGraph or LangChain or CrewAI, and this is completely non-deterministic workflows or agents. So here I have a know-it-all assistant. This is an agent that has access to multiple tools, each one with a very different domain. So this is an agent that has lots of knowledge about many different things. I called it Agent 47. If anyone gets the gist, you know what I'm talking about. And it has instructions, respond clearly and helpfully to questions, and use tools when appropriate. Pretty generic. Now let's take a look at the tools. They are very sophisticated tools. We have a tool that takes a mathematical expression and just tells us if it's valid or not. And we have one tool that can allow the LLM to jump a distance if we tell it to. We have another tool to basically get the weather, and another tool to do a web search. So we're going to go back to this agent, and we're also going to see how it relates to the observability needs that I talked about previously. The prompt is simple. What's the weather in Atlanta? Also, is 2 + 2 correct? If you want to, feel free to jump 5 feet. By the way, OpenAI always loves to jump. We're giving it a choice. You cannot jump if you don't want to. It always jumps. And this is actually where I'm going to crash the process, so I'm actually counting it to continue to deterministically choose to jump. Because LLMs want to appease us all the time. They're very good pleasers. Okay, so what we're going to see here is me just running the same old Dapr run command, and I'm just going to do Dapr run. And let's do agent 15, just so that later when I switch to my observability tools, we're not going to have to see all the previous runs I did. And yeah, let's run this thing over. So we're starting this. This is Dapr runtime coming up. It's loading the workflow engine. It's connecting to the underlying database. And we can see that we got the user prompt. So we have that. And we can see that it actually generated a bunch of Yes. So it finished. That was fairly quick. And the latest response back from Agent 47 is, yes, the current weather in Atlanta is 61. Yes, 2 plus 2 is 4. Great stuff. And it jumped a distance of 5 feet. Yep, it always chooses to. And this is great. Now, I talked to you about observability. Let's go ahead and see the ecosystem that Dapr Agents can actually integrate with. So if you want this in Zipkin, we can talk about the Zipkin interface. This is another agent I ran previously. And if you look at the tags, you'll see something quite nice. These are not your regular run-of-the-mill tags. Dapr Agents is slowly implementing interfaces that are not growing inside of the CNCF. So the open inference interface, for example, is something that's growing outside, but we are embedding it because it's starting to become an industry standard. And inside of Dapr, it's very important for us to make sure that we always use as many standards as we can. We do this by layering on top of gRPC of OpenTelemetry, Spiffy for agent identity and just regular microservices identity, and whatever we can. If you basically want to have this agent operating with OpenTelemetry, we allow you to do that too. This is what it looks like in Jaeger, for example, which is getting an OpenTelemetry trace from Dapr Agents. And as you can see, we've got all of the data, the tags, the input values, the duration. We can see how long each process took. And of course, if Dapr Agents can't speak OpenTelemetry, you should be able to connect it very easily to GCP Stackdriver, AWS X-Ray, and really whatever underlying OpenTelemetry system you have. And the only thing you need to do to get this is just input these 2 lines of code. You just need a Dapr Agents instrumenter and an instrument, and then a trace provider. This is something that's not specific to Dapr whatsoever. This you'll be getting from either OpenTelemetry or Zipkin or whatever your tracing provider is. Here we're just using Phoenix Arise because it's a great tool. So Phoenix Arise did require us to do some sort of modifications to Dapr Agents to be able to work with it, but the result is great. If you haven't heard of Phoenix Arise, it's, I would say, one of the most go-to observability tools for agents today, and we can take a look at this here. Unfortunately, the observability tool is great, but the UI needs a refresh to show you stuff. That's kind of like a 2015 like React just hitting the stage type of thing. Anyway, we've got Phoenix here with the entire workflow, and I'm just going to zoom out a little. And what we can see is the system prompt, the name, the role, the goal. So we basically traced all of those things. We can see the tools that the agent thinks it should be using in JSON format and the raw input if we want to. Then we scroll down and we can see the user. And that basically resulted in those 3 tool calls: get weather, calculate, and jump. And we can see the responses back from each one of those separate tool calls. And then the final output, of course. So Phoenix Arise is great, but again, you don't need to use specifically Phoenix Arise to see all this data. Basically, any form of observability platform you will connect into Dapr Agents, thank you, is going to contain this. So the last piece of what I'm going to show you here is something that is actually very, very difficult distributed systems challenge. Imagine you're running 5 of these agents on Kubernetes, and they're all running their own workflows, and they are non-deterministic because one prompt made one agent basically pick up 5 tools and execute them, and the other made it pick up different tools and execute them in totally different order. So how do we make sure that this is also reliable? Let's see if my claim is correct. It should be, because I ran it like 35 minutes ago. But again, the internet here is not great. So we will see. What I'm going to do here is, first of all, kick off another workflow, and we're going to give it a new ID just to keep things fresh. And now I'm going to go into my agent tool, and I'm going to be smart about the jump command. So I'm basically just going to do OS exit, a very abrupt exit to our program, and yeah, we're just going to run this, and let's see what happens. So it's starting. We can see the Phoenix Arise logs. We can see the user prompt. Yeah, this is great. But then, it executed get weather, executed calculate. Again, it's jumping. Thank you, OpenAI. But then it exited because, well, we crashed it. If you were to take any of the existing AI agent frameworks and just run them the way you just did, they will not pick up where they left off. And if you try to run them in multiple instances, they will run the same workflow, the exact same workflow with the same inputs in multiple places. Dapr Agents, and it's very, very important for me to make this known, is very much aware of all of your placements inside of Kubernetes. So if you're scaling out your system to 100 pods, and then you scale it to 200 pods, and you're now inserting 1,000 new workflows. It's going to make sure that no workflow basically initiates itself the same way twice, and every workflow is basically unique. Before I finish this, I'm just going to run this thing again, and let's see what happens now that I've just run the exact same thing. So as we can see, it picked up where it left off, even in a non-deterministic workflow. We've got the jump, and it crashed because I didn't remove the os.exit. Had I removed it, it would have completed to a successful completion. So please check out Dapr Agents. It's a great framework to write really reliable processes and run them on Kubernetes. We have a full Kubernetes tutorial that allows you to deploy it. And spoiler alert, you just need to do Docker build for your Python file, do Dapr init-k to install Dapr in Kubernetes, and you can run the exact same thing you saw on this laptop in a Kubernetes cluster, pretty much any Kubernetes cluster, on-prem, in the cloud, and connect it to your database. Dapr supports more than 30 different databases, so you can connect it to a variety of databases that your organization needs. So with that, I will bid you farewell, and thank you for coming to hear me talk.